Okay, guys, so we are on page 220. Now, there's going to be a little extra writing that you're going to have to do today. But again, please just kind of stick with me. I can use the equations and graphs and circles to solve problems. Your essential question: how is the equation of a circle determined in the coordinate plane? So here's how we derive the circle equation. If you look, you're given a center and you're given a point. Okay. If at any point you need to find the radius, you would use the center and the point to find the radius. Someone got fancy last period and did they did like an isosceles triangle to solve for it. It didn't work. So I don't recommend it. Okay. Huh? That I need a little bit more investigating on. I'm not gonna lie to you. Cause I mean, did it give him the radius? Yes, but after it was weird. You'll find it. I'll show you guys, but it was weird. I would just recommend put it in the formula. It never fails you, okay? Unless you just miss a sign or something, but that's a different story. So we have the center. We have this point now. Remember, the center is an HK. That's still XY, but that helps you show the positioning within the circle equation, okay? So the circle equation is x minus h squared plus y minus k squared equals r squared. Notice how everything is squared here, okay? Now here's what you're going to actually want to write down. The equation of a circle, we're going to add this to page 220 in our workbooks. An equation of a circle with center hk and radius r is x minus h. That's why it's kind of separate, because you don't want to be dealing with x and y, right? You wouldn't know where things go. X minus h squared plus y minus k squared equals r squared. I would also draw the picture. And these are just a few little notes that you're going to have to be aware of. First off, for h and k, you got to kind of think opposites with the equation. Now, why is that? Because if you look at the standard form, we have negatives here, which means if h and k are positive, they're negative in the equation. But if they're negative, then they become positive in the equation. So it kind of takes on that opposite form. You guys remember when you did translations last year with like linear functions and quadratic functions, and remember how it was always like x was always opposite? Like if it was negative, it's actually going positive, and if it's positive, it's going negative. It's the same idea here. Okay. The other thing you need to be aware of is that the radius is squared. All right. So in this case, if we want to find the radius, the actual radius, we're going to have to take the square root of r squared in order to find it. Okay.
Is this basically just like the same formula, except without that square root?
Yeah, it is derived from distance. A smidge different, only because it's a circle, but yeah, it does come from the distance formula. Good catch. Any other questions? Anybody still writing? What's that? Anybody else? Okay. Okay, so take a look at workbook, page 220 in the workbook. I'm going to have some extra problems here as well, but let's just take a look at this first. So in this case, we're going to identify the center, and we're going to find the radius. Now the center, remember, think opposites. If these are negative, this is our h, this is our k, but for our center, it's going to be positive, so this will be 2, 3. For the radius, we're going to take the square root of 25, which just gives us 5. So pretty simplistic, right? Nothing too big and spectacular. Now I want you guys to try these two on your own. Who has the center for number one? Center and radius for number one. Let's do it that way. Tony?
8, -5.
Very good. Very good. 8, -5. Radius is 4. Very good. And how about for number two? Go ahead, Tony.
2, -4.
Okay.
6.
Perfect. Any questions on that? So far, pretty easy stuff, right? Just the identification, not too bad. Is there anything I can address, though, before we move on? Now let's flip-flop the process. I want you guys to write this the equations given this information now. Go ahead. Show of hands who's still working on these. Anybody? Okay, so this should be x plus 14 squared plus y minus 7 squared equals 25. The second one should be x minus 3 squared plus y plus 13 squared equals that's 28. So remember, when you square this, you're squaring the whole thing. So this would be 2 squared and then the square root of 7. So that's 4 times 7. Okay? Any questions on this? Going once, going twice. Sold. Moving on. All right. So now what happens if we don't have a radius but we have a point? All right, so what is the equation for circle A? The notation for circle A means a circle with center at point A. So the first thing we're going to do is we're going to find that radius. Now, how do we set this up? Well, we're first going to set up that equation. So I'm going to have, in this case, x plus 1. Okay, so I'm using this, squared, plus y minus 2 squared equals r squared. Now, I'm going to take this point, I'm going to substitute in for x and y. So this will now be 1 plus 1 squared plus 5 minus 2 squared equals r squared. So this will be 2 squared plus 3 squared equals r squared. So this will be 4 plus 9 equals r squared. That leaves me with r squared equals 13. Now, this is what I can physically put into the circle equation. I don't have to do it, but if we absolutely need r, it'll be the square root of 13. Okay? Do you guys see the difference there? And now that we have it, we can use that radius and the center to write the equation. So here I'm going to have x plus 1 squared plus y minus 2 squared equals 13. Any questions? Okay. Is anybody still writing? Okay. I want you guys to give these two a shot. Now, use the points that are given to you. It will never fail you. I'm still trying to see if the fancy way will work. I don't know why it didn't, but I don't know. I'm going to try that out right now. Okay, show hands who's still working on these two. Anybody?
Can I go to the bathroom?
Did you do a pass?
Can I?
Yeah, go ahead. Okay, so let's take a peek at this. So here we have our center as 3, 0, and this point is looks like 1, -2. So first thing we're gonna do is I'm going to apply this and substitute in this. So this will be 1 minus 3 squared plus should be negative 2 minus 0 squared, and we're looking for r squared. This leaves me with negative 2 squared plus another negative 2 squared, which is r squared. And this leaves me with 4 plus 4, which leaves me with 8. So now that I have this, it looks like that triangle method would work. So now that I have this, I'm going to put that into our equation. So our equation should be x minus 3 squared plus y. You could just put y squared if you want. You don't have to do the y minus 0. That's up to you. Equals 8 in this case. Next one. Okay, so I'm going to, again, here is my center. My center is at negative 3, negative 1. My point here is negative 4, negative 4. So I'm going to have negative 4 plus 3 squared plus, looks like negative 4 plus 1 squared. And we're solving for r squared. This leaves me with negative 1 squared plus, this would be negative 3 squared. So this will be 1 plus 9 equals r squared. So we get r squared is 10, which means the radius is the square root of 10. So our final answer should be x plus 3 squared plus y plus 1 squared equals 10. Questions on that? How we doing? Pretty dandy? Pretty easy stuff? Good. I want you guys to have, I was hoping you guys would have an easy day here coming up. All right. Anybody still writing? I want to erase, so I want to make sure we got it all. Okay. All right. Last part. Determine whether a point lies on a circle. Circle Q has a radius of 7 and is centered at the origin. Does the point negative 3 square root 2 comma 5 lie on circle Q? So our first step is, again, let's write that equation for circle Q. Okay. So the center's at the origin, which is telling me that I'm just going to have x squared plus y squared, right? Because we're not going to subtract 0. Equals 7 squared, which is 49. Everybody with me so far? Okay, so now what we're going to do is we're going to substitute in this point. So this is going to look like parentheses. And parentheses are very important here, especially dealing with the radicals, guys, okay? This will be negative 3 square root of 2 quantity squared plus 5 squared, and we're seeing if that equals 49. So this becomes 9 times 2. Do you guys see that? You can't, if you forget the parentheses, this square in your calculator will only apply here, and it'll just multiply that by negative 3. So you get like negative 6. You don't want that. You're substituting something in, put parentheses around it, okay? So in this case, this will be 9 times 2, which leaves us with 18, plus 25. Ooh, it would help if that looked like a 5. Equals 49. All right, so 18 plus 25, we got 35, 40. What does that end up being? 43? Yeah? Well, that is not the case. In fact, 43 is less than 49. So what's happening here? Oops, sorry. I'm going to scoot back just a smidge. So this way, if you're writing this down, you can write it down. Okay, wow. Okay, this is just gone wacko. Sorry. Okay. So finish writing this down, and then I'm going to have to erase it. So we're dealing with 43 is less than 49, which means if it was landing on the circle, it would be equal. Kind of like that whole the idea of the triangles, right? The acute, the obtuse triangle, same idea. Okay. But in this case, we're talking about inside, outside, or on. If it was equal, it would be on. Okay. Is anybody still writing this down before I erase? Yeah, you okay? Okay. You sure? Okay, just checking. How we doing? All caught up? So what is this telling us? So if we're talking, if it's not on the circle, then it has to be inside or outside the circle. If it's inside the circle, that sum is going to be less than the radius squared. And if it's outside, that sum is going to be greater than the radius squared. So this one landed inside or outside. It was 43 is less than r squared, right? So it was what? This one was actually inside the circle. And when you graph this, you physically see that it's physically inside the circle or physically outside the circle. Okay. Anybody still writing? All right. I want you guys to look at this. Now for number 3, determine if these land inside or outside the circle. I want you guys to set up the equations and we'll go from there. I'll give you a minute. Or maybe 2. Show of hands, who's still working on these? All right, let's check them out. So looking at A, if it's centered at the origin, we're just going to have, in this case, x squared plus y squared equals, now we're going to square this, so this will be 4 times 5, which gives us 20. Okay? Substitute in that point, this will be negative 3 squared plus square root of 11 squared. So this will be 9 plus 11. So this will be 20 equals 20. So this lands on the circle. How are we doing with that? Questions? All right, letter B. In this case, we're going to have x minus 2 squared plus y minus 4 squared equals, if we square this, this will be 9 times 3, which gives us 27. Substitute in, we're going to have 6 minus 2 squared plus 3 minus 4 squared, and we're seeing if that equals 27. This is going to be, let's see, 4 squared plus negative 1 squared. So this is going to be 16 plus 1. So this will be 17, which is less than 27, which means this lands inside, outside, inside. Questions? Yeah. Did you make a pass? Any questions at all? I think that's it. Anybody still writing? All right, this is just a recap of everything. So we're going to pause on that, actually. I might use that a little later. So, all right, that's it. You guys can go in on homework. Those who are watching home, have a great day.